Hello everyone. Let us now discuss LeetCode question number 2471. Minimum number of operations to sort a binary tree by level. Here we are given with a binary tree. The task is for every level sort the nodes in an increasing order and store that in the operations. So for level 1 operations, increase the operations by the number of swaps, minimum number of swaps, and for level 2 and level 3, sort the nodes and count the operations. That means the minimum number of swaps to make it sort. Example, if you take this level 1, it is having only one node, so it is already sorted. Now come to 4, 3. The index where it is present is 0 and 1. If you sort this in an increasing order 3, 4, the index where it is present is 1. The index where 4 is present is 0. Now the actual indices should be 0 and 1. If you consider this is the actual index where it should be present, but it is present at 1. So swap the number at 1 and swap the with the number at 0. If you swap these two, then you will get 3 and 4. And the second thing which we need to do is swap these two indices. Now as 1 has become, so 3 has become 0 at the index, come to the index 0, and 4 is having at index 1. Now swap these two and you get 0 and 1. Now these two are at the correct indices in a sorted way. Come to level 3, 7, 6, 8, 5. These are the indices in the binary tree. Now sort them by element 5, 6, and then 7 and then 8. So where are they present? Let us store that 2 for every element. 5 is present at 3, 6 is present at 1, 7 is present at 0, 8 is present at 2. But 5 should be at 0, 6 should be at 1, 7 should be at 2, 8 should be at 3. That's why we have sorted in element by element 0 and 3. 5 should be at 0 but is present at 3. No, swap the elements at these two. Swap this. Now our array becomes 5, 6, 8, 7. So the index where 5 is present is 0, 6 is present 1, 2, 3. In the vector 5, 6, 7, 8. Now 5 is present at 0 and 6 is present at 1, but 7 is present at 3 and 8 is present at 2. Now the number of swaps till this we got is 1, and here we got 1 swap. Now consider the next element 6 and 1. So it is at the correct index position 0, 1, 2, 3, and 1 is equal to 1, 0 is equal to 0, and 2, and here 3. Now 7 is at index 3 but it should be at index 2. So swap the elements at 2 and 3, then 7 will come to the actual index. So if you swap at index 2, index 2 and index 3, if you swap these two, so increase the count by 1, the array will become like 5, 6, 7, 8. So 0, 1, 2, 3. If you write this array, the sorted array, once again 0, 1. So where 7 is, it is at 2, 8 is at 3, 0, 1, 2, 3. So 2 is equal to 2, 3 is equal to 3. So there is no need to swap, and we have swapped for one time here, for the second time here, and for the third time here. Now 9 and 10. So if you sort them, it is the same order, so there is no need to swap. So we'll be returning 3. If you break down this question, we need elements at each level. This is the first step. So the second step is minimum operations. We need to do these only 2 steps. So how do you get level after a level? So we can use a breadth first search. The first thing which we do is we need the elements at each level and the minimum operations. So this will be converted to an array, temporary array, and here a temporary array, and then we need to calculate minimum operations or minimum swaps for this array and increase this to the answer. Now, do we implement this breadth first search? So, take a queue and push the root node. So, you'll be having 0. Queue is having the node. Take that node 0, and if it is having left or right, push that into the queue, and it is containing the element 0. Now push that into our temporary array and count the minimum swaps and add it to our answer. I will be giving you the algorithm for this. So the algorithm is queue tree node, create a queue, and then push the root node into our queue, and then while queue is not empty, size is equal to queue dot size. Temporary vector for I is equal to 0 to size. Current node is the front node of the queue, and remove that from the queue. Temp dot pushback, current node value. We need only the values to be stored in this temp, and if it is having the left, push the current node of left into queue. If it is having the right, push the current node right into the queue. If the current node is having the left, push that into the queue, and if it is having the right children, push that node into our queue. Now after this, we need to consider returning an answer. Now this should be increased by minimum swaps of temp. So we'll be constructing a function for this minimum swaps, and after this while loop ends, return our answer. How do we do this minimum swaps? Take this array vector of int. As I said, we need to store this with the indices. N is equal to array dot size, and we'll be storing the element and the index where it is present in V. So I iterate through this N and store array of I comma I. So as I said, we'll be sorting this V, and the swaps initially is 0. While I is less than n, I is equal to 0, I is less than n, if v of I dot second is equal to I plus plus. So it is at the correct index. Else increase the swaps and swap v of I and v of I dot. After that we'll be returning this swap.